Good afternoon, student. Good
Good
afternoon.
afternoon, sir.
Good
Good
afternoon.
afternoon.
Good
Good
afternoon, sir.
afternoon, sir.
Good
Good
afternoon.
Good
afternoon.
afternoon, sir.
Good afternoon.
Good afternoon, sir.
Good afternoon. I can start a recording. Okay. So, okay, let's start taking attendance. 25 aerospace, absent 26,
Yes, sir.
27,
Yes, sir.
28,
Present, sir.
29,
Yes, sir.
30, roll 30, absent.
Sir,
Yes.
sir, I'm civil engineering 77. Actually, I am facing some technical problem.
Okay.
After this meet, sir, I am trying to install the Google Meet app and then I am trying to log in.
Okay, no problem. Okay. 77 civil. Okay,
Yes, sir.
give an attendance, fine. Then 78, 78 absent, 79,
Present, sir.
80,
Present, sir.
81,
Present, sir.
82,
Present, sir.
83,
Present, sir.
84, civil 84. Okay.
Present, sir.
Okay. Civil 84, then civil 85.
Present, sir.
Just a minute. Civil 85. Civil 86, 87,
Present, sir.
88,
Present, sir.
89,
Present, sir.
90,
Present, sir.
91,
Present, sir.
92 absent, 93 absent, 94 absent, 95.
Present, sir.
Okay. 96. Sorry. Then, not 96, it is 61. Okay. CST 58 absent, 59. Okay. Who is this? Just a minute. Just a minute. 58 CST absent. Then CST 59 absent. 60 absent. 61.
Present, sir.
Yeah. 62.
Present, sir.
63 absent. 64 absent. 65.
Sir,
Present, sir.
64 present.
64 present. 64. 64 present. Yes. 65. Then 66 absent. 67.
Present, sir.
68 absent. 69.
Present, sir.
70.
Present, sir.
Okay, 70 present. Then electrical 49,
Present, sir.
50,
Present, sir.
51,
Present, sir.
52,
Present, sir.
53,
Present, sir.
54,
Yes, sir.
55,
Present, sir.
56, absent. 57,
Present, sir.
58,
Present, sir.
59.
Present, sir.
Okay, electrical done. Then electronics 35,
Present, sir.
36,
Present, sir.
37,
Present, sir.
38,
Present, sir.
39,
Present, sir.
40.
Yes, sir.
Okay, 41 absent. 42, 42 electronics. 42 is present. Okay, IT 53,
Present, sir.
54,
Present, sir.
55,
Present, sir.
56 absent. 57,
Present, sir.
58,
Present, sir.
59,
Present, sir.
60,
Present, sir.
61,
Present, sir.
62,
Present, sir.
63,
Present, sir.
64, 64 present. Then mechanical 49 absent. 50,
Present, sir.
51,
Present, sir.
52 absent. 53,
Present, sir.
54,
Present, sir.
55.
Present, sir.
Okay, 56,
Present, sir.
57,
Present, sir.
58,
Present, sir.
59,
Present, sir.
60, 60.
Present, sir.
Okay. Then
Present.
metallurgy. Yes, yes. Metallurgy and materials engineering 25,
Present, sir.
26,
Present, sir.
27,
Present, sir.
28,
Present, sir.
20, 29,
Present, sir.
30 absent. Then mining 25,
Present, sir.
26,
Present, sir.
okay, 28,
Present, sir.
27 absent, 28 present, 29
Present, sir.
30
Present, sir.
present. Those who are
Sir,
absent, once
CSB
again,
66 present, sir.
just a minute, one by one. Aerospace 25 absent, then aerospace 30 absent, civil 78 absent, then civil 92 absent, 93 absent, 94 absent, then CST 58 absent, CST 59 absent, 60 absent, CST 63 absent, CST 66 absent,
Sir, 66 present, sir.
66 present. Okay, given. Okay. Then 68 absent, CST. Then electrical 56 absent. Then electronics 40 absent. Then IT 56 absent. Mechanical 49 absent. Then mechanical 52 absent. Then metallurgy and materials engineering 25 absent, 27 absent. Okay,
25 present, sir.
just a minute. Just who is present?
MMB 25.
Sorry, MMB 25 present. Sorry, I did one mistake. Mining 27 absent. Okay, and MMB 30 absent. Okay. Yes.
Sir, AMB 025, sir, I'm present.
AMB 025. Name?
Sir, CSB 058.
Just a minute. Name 20.
Suchishat, sir. Kailasam Sai Suchishat.
Kailas. Then
CSB
somebody-
058.
CSB 058. Name?
Oyandas.
Yeah, on absent. Sorry, present. Yes. Okay.
Sir, electronics 42, sir.
Electronics 4-2. Name?
Viral Yadav.
Yes, given. Already given. Okay. Attendance is over. Then one by one. Sorry. Next is
Sir, I
yes.
am facing a problem, sir. I can't fix it. Actually, sir, the people window is just popping up after going out automatically, sir. Can you help me?
Your roll number?
Sir, 77. Civil
Seven,
engineering 77.
7. You told once, yes. So actually, when you are trying to log in from other uh, mail ID, okay,
No, sir, no, sir. It is
okay,
my G Suite ID.
okay, fine. No problem, no problem. I have taken the attendance, okay.
No, sir. Can you,
Yes.
sir, help me? Can I share my screen, sir? I can't fix it from morning. The
Okay,
class was
what is happening?
disrupting. Can I show, sir?
Yes, show it. Share the screen. Yeah.
I can't, sir. This is a
Okay.
very
Understood.
problem, sir.
Understood. See, I'll tell you, if you have any problem related to this login issue, so there are some IT guys who are supporting team. Those person will help you. I am not responsible for this.
Okay, sir.
Okay.
How can I, sir, contact, sir?
Okay. Maybe uh, what you can do through your class representative, you can try to
Okay, sir. Okay, sir.
okay
Sorry, sir.
contact somebody. I don't know exactly who will help you, but definitely that problem will be resolved with the help from IT persons. Okay, there are some assistant people. If people are facing some issue, they will provide. Okay, and it is, I think, it is said that student cannot share the screen. That's why you are not able to share. Okay.
Yeah. Actually, sir, the people window where we can the list of everyone in the meeting.
Okay.
This is popping up and popping out automatically. I can't do
Okay.
anything.
Okay. I understood. So that type of help you have to take. Now let's go back to the problem sheet. So what I did, I have noticed that there are, I think, some problems with some issues. I have posted in the classroom that assignment 3.1, 3.1 problem 5, 3.1, just a minute. Problem 5, there is one dimensions 5.2 meter, 5.2 meter. So that I have changed this to 6.4 meter. That is the correct dimensions. And okay, why not? Let me share the screen. You will understand what I want to say. Okay. Are you able to see the screen? If it is, let me know. Yeah. Yes.
Yes, sir.
Okay. So assignment 3 problem sheet correct figures 3.1 problem sheet 5 and 6 and 3.21. What are those? Let me check it. So what I have given you 3.1, this one. Yesterday I have given the updated one. That is yes, this problem. Actually, it is 5.2 here, and it is 6. It's supposed to be 6.4. By mistake, it was 5.4. Actually, what happened in any of the exam, I believe we have changed the data 5.2, 5.2. But it is actually to match this results, it will be 6.4. Okay, that is one. Next one, this figure. This figure is something else, and this is done basically. Initially, there are two problems. Then we have discarded problem, the upper problem, and lower problem was like this. There are two problems here, and one is located at top at the bottom, and whatever results have been shown, that is corresponds to this figure. So initially figure was wrong. So I have changed yesterday night. And this also same thing, 6.4. It was initially 5.2. It's supposed to be 6.4. So based on that, you have to update your assignment if you have already done. Okay, then change and update accordingly. Now coming back to this is the problems 3.1 and 3.2. Now tell me what are the problems you need help from me. Let me tell you last day what we did. Problem here. Okay, this is already done. Then 5, yes, this is already done. Then somebody asked 7, so this is already done. Then I have told you this problem. This is already I told. Somebody asked for 5 also. Yes, this one already done. Now tell me for problem sheet 3.1 and 3.2, what are the problems you need help from me? Let me know. Tell me.
Sir, I have a doubt in the sixth problem. So 3.16.
Okay, 6. Yes, this one. This one.
Yes, sir. Sir, I have a specific doubt, sir. If we make the FBD of point D, so joint D, so the horizontal forces will balance each other. So, sir, FCD and FDE will be equal from the horizontal force balance. But, sir, the answer...
No. That is true only when there is no external force. You have some misconcept. Let me tell you. You going to say, so first of all, for this problem, we'll start. Okay, just give me 1 minute. Let me open the solution also. So we'll start from say, if we do free body diagram for H here, then we will get BH equal to 0. And this is symmetric problem, correct? This is symmetric line. We call symmetric line. The structure is symmetric and it is told neglect horizontal reactions at supports. Okay. So there is no horizontal reactions at A or E. So definitely whatever value you will get for this, same value will get here. This same value will get. Okay, this same value. That way you will get the results. Now, if somebody want to draw free body diagram for H, joint H, BH will be 0. Somebody want to draw the free body diagram for F, then DF will be 0. The doubt you told, what I told, if this is 0, basically it is now like this. Now it is like this. And some external force 1 kilonewton here. And this is free body diagram of joint D, FBD of joint D, DE, DC, and DG. This is 0. Now what I told, that you are telling that this DG will be 0, correct? As per your understanding, and these two value will be same. That is true only when scenario is like this. In absence of the any external force here. 1 minute. If there is no external force here, then only that is true. That DJ will be 0 and DC will be DE. But here problem is different. 1 kilonewton load has been applied on the same joint. That's why it will not be same. And there will be some component of DG also, some value will be there. DG, yes. some value will be for DG, and DC and DE. What is DC? CD basically. DC is this, and DE, yeah, D is this. Those are different. Understood this point? That concept was valid only there is no external force applied to that particular joint. Yes, got your point?
Yes, sir.
Okay,
Yes, sir, I
fine.
got it.
Yes. Okay, fine. Maybe to solve this, the idea is that you start with either H, then F, then you start maybe for joint A, only particular reactions. So these two can be known. Then once A is done, already this 0 you know. If this is 0, then this value and this value will be same. So that idea we can get from, say, as I told, start from A, then H. H you have already done before. Then move to maybe B, then move to C, then move to G. Start from A, then H, or maybe you can start from H itself because you are sure. H, then A, then B, then C, H, then A, then B, then C, then G. This sequence you can go, and you can tell also due to symmetry, symmetry, should write this one, symmetry of geometry, plus if symmetric is geometry but load is not symmetry, then that will not be true. Due to symmetry of geometry and loading symmetry or load applied symmetry, loading symmetry with respect to axis CG, left side, left portions and right portions, okay, the corresponding symmetry portions, members will carry the equal loads. That is one way you can save some time, but you have to be careful. Geometry is symmetric, as well as loading is also symmetric with some respect to some axis. Here it is, or some member, CG. That's why left side and right side are same. Because and that loading is symmetry means not only external load, it is true for reaction force also. Symmetry, from where you are getting symmetry? Because geometry is symmetry. This 2 mm, 2 meter, 2 meter, 2 meter, then this is also 2 meter, and looks angles are equal angle, correct? Symmetric angle, similar angle basically, and loads are all 1 kilonewton in vertical direction. So it is, if you consider this line, then left side and right side it is symmetric. You solve this way. Okay, any other problem you need help?
Sir, in question number 7, how to find the force in member CD?
On that day we have discussed, no, this one. You see the last day's that lectures, you will get that. We have discussed rigorously, I believe. Yes, somebody asked last day. Are you there in the last class? Hello?
Yes, sir, I was there, but my internet data got finished, so...
Okay, no problem. You will get that video. So have you read the video? So
No,
have
sir.
you? Okay, you do that. You will get the answer. Okay, don't worry.
Okay,
You will
sir.
get that.
Sir, in question number 6, sir, I had solved, but the answer I was getting not matched with that.
Okay, let me check if I have solutions. Let me check just a minute. Now, actually, when you have tried, the problem was something else before.
Yes, sir. After correction of that diagram also.
Okay. Let me check. A little bit change or huge change?
Sir, huge change.
Okay, let me check. Okay. Let me check, just a minute. Just give me 1 minute. Where is the solutions? Let me look. Okay. Okay. Which one you told? This problem, correct?
Yes.
Okay, you check one by one. So what I did, let me check with this color. So for so as I told, the horizontal reactions are 0. It is told problem. So I want to take that moment equilibrium equation with respect to joint A for the entire structure. So what I have to do initially, I will show this only. I will remove the support and I will show the reaction force. Say AY is EY, then this. So 1 kilonewton, 1, and dimensions are given. You have to draw the dimensions also in free body diagram. Okay, so FBD of whole structures. Take moment with respect to A and you will get EY equal to 2.5 kilonewton. Just check whether you are getting this or not.
Yes, sir, getting.
Okay. Then summation Fy equal to 0, you will get AY equal to 2.5 kilonewton. Correct. So 1, 2, 3, 4, 5. If it is 5, then 2.5, 2.5. You are getting this also, correct?
Yes, sir.
Okay. Now, free body diagram of joint A. Okay. So what I told, I do prefer now this way. All is tensile, AH, BH, sorry, AB. This is 1 kilonewton. This is 2.5 kilonewton. And this is A. FBD of joint A. So summation Fy0 will give AB equal to this value. Are you getting this?
Yes, sir, compressive nature.
Okay, 3.35?
Yes, sir, yes, sir.
Okay, summation Fx equal to 0, AH equal to 3 kilonewton.
Yes, sir.
Okay, that is done. Then as I told, for this H, HB will be 0. And HA equal to Hg equal to 3 kilonewton tensile. You got this, correct?
Yes, sir.
Okay, up to that you got. Now here for joint H, let me check. 1 minute. For joint H, sorry, no, joint B. This FBD of joint B. So for B, let me check it. So this is one force. This is another force. This is already 0. This vertical. This one is 0, correct? BH is 0.
Yes, sir.
So yes, then this is BG, BC, BA. And theta is here, this theta 2. This is theta 2 basically. Theta 2 was some 63.43 degree. Okay. Then I'm talking about this is BG. Let me check. BG sine 2 theta 2. Sorry, 2 theta 1. This is 2 theta 1. Let me change the color. This is 2 theta 1. So what I wrote here, let me check. BG hopefully sine 2 theta 1. This is BG sine 2 theta 1 equal to 1 multiplied by cosine theta 1. What I want to do, as these two forces are along this x-axis, in y-axis, if I want to decompose the things, this y-axis, so I can get Bg value is minus 1.11. Are you getting this?
No, sir.
Okay, you are not getting this Bg value.
Sir, in member BC, I am getting 3.354 kilonewton.
No, you
Compressive.
you are getting wrong, something wrong. So what I want to do, let me draw once again. So this is the joint. This is BC. I understood. This is BA. Okay. This is BA. This is B. Then this is 1 kilonewton load. And you have BG member, some BG member like this. BG is not it. This is your this is the given things, correct? What is your problem?
Yes, sir.
So this is a B. So what is the easiest way to do? You draw one line which is perpendicular to this. Okay, which is perpendicular to this. Why? If I want to do this way, then I have say here is some angle alpha, here some angle beta. So one cosine beta will be Bg cosine alpha. Because this is 90 degrees, there will be no component of that. If you do that, then you will get Bg value as minus 1.1178. You note down this. You will get that. Definitely you will get that. So somehow you are doing the mistake in calculation of angle, I guess.
Okay, sir, I will check, sir.
Actually, what you did for you, say BA, let me check. This BA is already known. This was already known, correct? From A. This is already known. It was minus 3.35. Are we using that way? 3.354. Okay. So what I am doing, I am showing it is away. But in the expression, I will put that one as a negative for BA. Maybe that one you are doing mistake. Somehow you are doing some mistake. If you do carefully with the angle, definitely you will get Bg equal to minus 1.1178. A little bit that numerical error maybe that is allowed. If you are getting this, then definitely you will get this Bc value this. Okay, some numerical error you are doing, maybe in considering not numerical error, basically this alpha and beta, this calculation may be little, you have to check once again. Some mistake you are doing, okay, nothing else.
Okay, sir, I will check once again.
Yeah, sure. Okay.
Sir?
Yes.
Sir, I have a doubt regarding the submission of the documents.
Yeah.
Sir, so the questions, should we solve them in a clean A4 size sheet, or doing it in a book will also be okay?
No, I do see if when you are using book, it's notebook, correct?
No, sir, no ruled lines. Plain.
Okay, notebook, plain notebook. Yeah, that also you can do. No issue. But problem is you have to be careful that when you will be doing scanning it is coming correctly. I have no issue. You can do that one also. Because when it is offline, students supposed to submit that. So we always give the guidelines that submit your assignment in A4 pages. But here nothing is there. You will not submit anything hard copy. Everything is with you. So even if you are doing fresh in your notebook, quite not ruled one, that is also okay for me. No, don't worry.
Okay, sir. Thank you, sir.
Yes. Any other questions you want? Anybody? So this is done then. This 6 is done. Any other problems? Speak out. Any other problem you want to do? You want to tell me you are facing issue?
Sir, is it okay to ask something for the previous assignment?
Okay, I will go there. Before that, we have to finish this first.
Okay, sir.
Okay, I will take that questions. Don't worry. Yeah. Any other questions?
Sir, actually, I think most of us don't have questions because most of us have not
Didn't get
started,
time.
I think,
Okay, fine, no problem. Okay,
attempting this assignment.
okay, fine, fine. So what I can do, I can quickly give you the steps for the solutions. All
Okay,
questions. Okay.
that
Yes.
will be very helpful.
Yeah, yeah. So one I have already did on that day. For two, okay. For two, so this is the problem given, and you can see that it is having here one. Yes.
Sir, is this all these trusses massless?
That is the assumption at the beginning. Yes, it is massless.
Okay.
Yeah, yeah. So it is massless. Okay, assumption was that. So if I go there, this problem. Okay, the drawbridge is being raised by a cable EI. The four joints loading shown results from the weight of the weight of the roadway. So determine the force in the members. Some members is given EF, which is EF, EF, this one, and DE, DE, DF, DF, CD, C, D, this one, and FG, FG, this. Actually, in reality, it is showing the 2D view, correct? But in reality, it is 3D view, like this. Okay. So if it is ruler 1 here, there will be more ruler here also. Sorry, more ruler. So if it is 3D view, I want to write it. Give me, yes. So it will be looking like this. This way it has been. So if it is one line here, one line also will be here. It is showing here 2D view, but it is in reality 3D view, correct? So everywhere this roller will be there. This side will be roller. But we are showing this, we are projecting like this, and this is the side view. And that side view is looking very simple, 2D view, two-dimensional view. Okay. Now, to solve this, first of all, you have to draw the free body diagram. You can draw for the entire structures, or even not. You draw the free body diagram for first of all, you start with free body diagram of entire breeze. You draw ABD of entire breeze. So if you draw the free body diagram of entire breeze and take moment with respect to this point is A and use the equilibrium equations, you will get value of EI. This EI will be, this value you will be able to calculate to draw the free body diagram of the entire structures. So what you have to do, you have to remove this support and you have to show by this force, this is the reaction force. Say this is NA, then another reaction force due to this pin, sorry, this is NY, NX, NAX, NAY, this is X, this is Y, take the moment respect to A, but you have to show this, you have to show this NAX, NAY, although you are taking moment with respect to point A, that NAX, NAY will not be used in the expression, but correct free body diagram you have to draw. Then take moment with respect to this and you can find the value of EI. You can get the value of EI. Once you know the value of EI, you know the EI, then draw free body diagram for joint E. These two will be known. Then once you have done E, then you move to D. Then this value will be known. Once you know this D value, this, then you go for free body diagram of F. You know this, and these two are unknown. So this will be the step. First, whole structures, remove the reaction support, and represent by two reactions NaX, NaY at A. Take the moment with respect to A for the entire truss or bridge to get this value of EI. EI will be known first. Then draw free body diagram of joint E. You will get two unknowns connected to joint two members, unknown forces of the two members connected to joint E. Then move to D. Two unknown value will unknown force of the members will be known. Then move to F. That is done. And then this structure is not actually internally stable, because you can see this is quadrilateral here, correct? This is the quadrilateral here. So we will not take any moment. So it is not a rigid body. It is basically we call it will collapse basically due to the load. So we will not take moment. No moment equations will be used for such non-rigid structures. So what we will do, as it is told the angle is 120 degree or 60 degree, so we will draw free body diagram for G only first. For this free body diagram you draw this value and this value will be known. Then it is called, we have to calculate B and BD. Where is BD? BD, this member, and BE, this member. Okay. Then draw free body diagram of G first, then move to E, because once this is known, this two can be known. Then you move to B. Then this is known, this to be known. This is the steps you have to follow to do this. Okay. For these problems, so equiangular truss. Okay, equiangular truss, all are say A, that way it is even given, correct? So equiangular truss, so that means considering that one, if it is equiangular truss, what will be the angle?
60 degree.
So if it is 60 degree, it is 60 degree, it is 60 degree. Then these two are same. Then definitely it also will be 60, correct? All are 60 degree. You got that one. So what you have to do, first of all, you draw free body diagram of entire truss. Here one directions, because you see this is roller, this is hinge. So this and this is the members. So this is C, this is E, this is point A, this is L, this is X, Y, N, C, Y, N, C, X, N, E, Y. Okay. First, take moment with respect to C. Moment with respect to C equal to 0. NEY will be known. You know NEY. Then summation Fx, summation Fy will give the value of NCY, NCX. That portion is done. That means this reaction force you have already calculated. Okay. Because this problem told you have to calculate the forces for all members. So reaction force you have calculated. Then the step you can start with A. These two unknown will be known then. Okay. Once A is done, then draw free body diagram for E. Then this and this will be known. Okay. Then you move to free body diagram of E is done, correct? Once E is done, you go free body diagram of C. You can
use symmetry here?
You can use symmetry. No, because load is not symmetric.
Yeah, okay.
Okay, very good question you ask. Yes, thank you for being asking these questions. Okay, yes, we cannot use, because this is loading geometry is symmetry. No, geometry is symmetry, that is correct, but boundary condition is not symmetric. Here it is hinge, it is roller. So here you have horizontal reactions. Okay, that horizontal reaction will be same as L. You can understood.
Yes, I got it.
Yes, so you cannot use. So start from A, then go to E. This two will be known. Then you can move to C also. Then this two will be known. Then you can go to B. Then you can move to joint F, and finally D I have not done yet. Check for D. Check for D. What you what you have to check that whether equilibrium condition is satisfied or not. I should write here. So start with joint I to say n. I to n. Okay. N minus 1. Start from I equal to start with joint 1 to n minus 1. You do this, you will get the unknown. Then for nth joint, check for equilibrium. Sometimes maybe you can get that it is 0.05, some force imbalance. It is acceptable because that is numerical error. You might be taking 2 or 3 digit numbers. So to solve this problem, what is the idea? That you have to start with first whole structures free body diagram, take moment to get the unknown reactions. Then you try to find out from which locations joint you want to start, where there is a minimum number of unknown. Say here I can start from either either E, C, then A, then B, then F. Then all members unknowns are known. Remaining is nth one. I thought let it be last one is D, joint D. For joint D, I will check the equilibrium conditions whether it is satisfied or not. What I'll do, as it is joint, no, summation fx equal to 0, summation fy equal to 0. Whether it is been satisfied or not, I'll do. So I'll write summation fx equal to dot and equal to say 0.05. Say for example, it is 0. We are assuming 0 because there will be some numerical error. 3 is done. Sorry, this is 4. 5 is done. 6 is done. 7 is also done. Now this is done. Then I will come this. This is moment Truss problems, method of sections. We have to calculate force for BC and CG. Where is BC? BC, this member. We have to calculate this member and CG, this member. These two members, for these two members, we have to calculate the unknown load carried out by these two members. 3.2, okay. Problem 2. So to solve this, and you can see this is here, this is roller, correct? One support, this is hinge, 2 support. So externally 3 support, and all are triangular case. So as I told that expression m plus 3 equal to 2j, that will be valid. You can check that. J is the joint, m is the member. No member is missing. All have 3 members. They have constructed one triangular shape. So it is rigid structures. Okay, that you can check it here. Now after that, to draw this, to calculate these two unknowns, what I can do, I can have some imaginary line which will cut these structures into 2 parts. But either I am taking lower part or upper part. Either I am taking lower part or upper part. That free body diagram will consist of reactions from the supports. So if I draw the free body diagram of entire structures, let's assume that this is the structures. Due to lack of time, I'm not able to, sorry, this is wrong. So let it be, wait. Because if I am not drawing properly, angle will be some different. Let me delete it and to draw it properly. So what is, wait, this is one vertical line of this length, then this is one line like this, Actually, I should not draw this way because that member should not be continuous. But due to the issue with this angle, I am doing this way. I'll tell you. I supposed to draw this way basically. This way one triangle, then 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 maybe this way one triangle. Now, if I draw the free body diagram of entire structures, whole structure, this is L, and the length you have given, it is given 30 degree, then this is A, this is A, okay, and here this is also 30 degree, and you give this member. Let's draw the reaction force. It is, so this is X, this is Y, N A Y, and maybe this reaction force is like this, N A X, and this is the ruler. A ruler is supposed to have only one reactions, that is perpendicular to the structures. So this is N E. Now, one thing I want to say that from the geometry, if you draw everything correctly and take moment with respect to A anticlockwise equate to 0 here, then you will get this value of any. Any value you will be getting 2 by square root 3L. Okay. See, if this is A, this is A, this is A, all are 60 degree. So you will get any value is this. Any value you can get from the moment equilibrium equations, that is 2 by square root 3L. Okay. Then you consider this imaginary cut. Okay. This imaginary cut and consider the left portions, because this unknown, this force we have calculated from there. So what we can do, we can draw, let me draw this. So this, this. So what we got, let me change the color. So we already got this reaction force along with the directions. This is NE. Okay. Now, and that is passing like this. And you draw this. This is the so where we want to take the cross sections, we will expose that forces there only. It is continuous. Now this is exposed here. Okay. This is exposed here, and this force has been is exposed here. So this is our cutout. This is the sections. So in that way, it is showing that this force is okay. This is, don't forget to give this L load here. Okay. So here this point is F, and this is G. Then this force is FG, and this force was, this is C basically, BC or CB, and this force was CG. The BC, CB, and CG we have to calculate. So we'll reach to this. Geometry also you know. Then this is x-axis, y-axis, FBD of right sectional part. Okay, first of all, take moment with respect to this point. Moment with respect to G, equate this to 0. This is moment with respect to G, then you will get CV value. Then use summation fx equal to 0, summation fy equal to 0 to get the other unknown. Okay. Next is you have to calculate the forces member in DE and DL, which is DE and DL. Okay. So what you can do one section here. You can take one section here. Then this force will be exposed is the scale, and I'm drawing only that portion. Okay. This portions. This is DE. This is E. You have to draw entire things right side. And wait 1 minute. Let me draw a little bit better way. Okay, this one, then this one. So this one is like this. So, and this maybe this is the cross sections. So what we'll write? This force basically KL. This is towards L, and this force is EL. This force is ED. This is point E. You draw the entire right side. So now this way, if you do this and take moment with respect to this problem, if you take moment with respect to L and equate this to 0, then ED value will be getting ED. If you are getting ED, okay, then you take this value of ED and ED summation fx 0, summation fy equal to 0. Both use this and to get ED, EL and KL. But it is told D and DL only. Okay, this has not been told. Then also I don't need. Then if I know this one, then I will draw once again. I want to do this mixed mode. This is DE, this is D, and this is DC and DL. FBD of joint. I want to take, say, let's take it is combined mode. Okay, mixed mode. So you draw the free body diagram of D. This one you know. Summation fx, summation fy will 0 will give this DL, sorry, this is DC and DL value. I want only D and DL. So mixed mode also you can apply. It will save some time. You can have some other alternative also. So like once you have done this, and second one people can try this way also. This is the sections you can take. These sections already you know D, correct? Already you know D. So if you can take these sections, if you take these sections, then KL value you know, then this unknown, and this unknown. 3 unknowns can be taken. That also can be done. So let me tell you once again. The change color. Maybe first one is this. Sorry. This was the first cut. Then I told for this you can go mixed mode, or maybe you do this one first, then do this cut. Then this will be exposed, this will be exposed, this 4 will be exposed. 4 force will be exposed. Out of 4, already you know KL value. So other 3 you can calculate from taking the moment, one moment. Other is summation fx, summation fy. One thing let me tell you, say many times what we are doing moment with respect to say point O, summation fx equal to 0, summation fy equal to 0. Instead of that, Somebody can try this way also. So these are the 3 points. Those are in a single plane, coplanar, but not concurrent. This is A, B, C, or maybe this, or equilibrium problem also. Somebody can try this also. Summation Fa equal to Ma equal to 0, summation Mb equal to 0, summation Mc equal to 0. Instead of this one moment, two force equilibrium, somebody can use 3 moment equilibrium itself. If those three points are not collinear, okay, but in the same plane. That way also we can solve the problem, because whether you are taking summation fx, summation fx0, fy0, m moment, one moment is 0, that is analogous or equivalent to take 3 moments for different 3 points which are not collinear, which is not which is not collinear. Yes, it is not in a single line. It is not 3 points, not a single line. If this is the case, 3 points, they are not collinear. You can take 3 moments also. It is equivalent. Okay. Okay. Then this one, determine the forces for BC and CI. BC. This is, what is B? BC. This is B. C means this member, and CI. CI. Okay. Take. This is the cross section you take. Okay. So if you take that cross sections, this, this, so this is 18 kilonewton, 10 kilonewton, distance 2.25 meter, 2.25 meter, 3 meter. You have to give proper dimension, okay, the way you used to give this. Then basically one, so maybe this is the cross sections, imaginary cut. This force is HI, this force is CI, this force is CB, and some imaginary line, draw it this way. These are the imaginary line. This is J, this is B, this is I. Okay. So you have to calculate BC, BC, and CI. CI. So you have to find out that which cross section you want. You have to be very tricky in that case, that after taking the cross sections, the unknowns will be exposed. Initially it was internally, now it will be external. It will be exposed to the atmosphere, and the imaginary cuts of the section will be such that those unknowns, required unknowns, will be exposed. That's why targeting this BC and CI, I have taken this number. Now take moment with respect to I equal to 0. You will get CV values, then summation fx, summation fy, you will get the other values. Next is 6. Okay. For this, all are 45-degree right angle triangles. So one is 45 degree, other is 90 degree. By inspection, you can check this is 0 basically. This is 0. You can understand. Okay. Now for this one, this is the cross members. There are 2 cross members like this. If you see from the side, it will look like this, here and here. Okay. Say this is GL and EM. So this is GL, sorry, and FL. This is F, this is L, and this is E, this is F, this one. So F, N, and this is E M. If I see from the side. Now, if you consider this is the tensile load has been applied like this is the tensile force applied like this one force. Okay. So you can assume that if you apply this tensile force, this will be tensile. Assume that Fn is tensile, and if you apply this also tensile Gm. These two members are tensile. You assume it because cross member and it is incapable of supporting compression. You assume these are tensile. This member, two members are tensile. So definitely this will be compressive. This will be compressive. This one and this one. This member will be compressive. Based on that, you continue to calculate unknown of Mn. Find retain this. Just remember, Truss is shown is comprised of 45-degree right angles, cross members in the center, two panels, slender thigh, incapable of supporting compression, retain the two members which are under tension and compute the magnitude of the reactions. So if there was a tension, you have to calculate the magnitude of that force and also member of the Mn. So what are the unknowns you have to calculate? You have to calculate because we don't know. Maybe this and this, or if it is I'm wrong. So this what I have considered that tension is Fn and Gm. Then I have to calculate those value. If I am right, it is tensile, fine. If I am wrong, from the beginning I have to start to consider that Fl and Em, those are tensile, and this Fn and Gm are compressive. So, as per our intuition says that if we are applying this force, these directions, this will be Fn will be tensile, and due to this load, this Gm will be tensile. This first assumption, then we will check that. Then, if these members are not there, what you have to do to solve this? So we have to take that moment, but it is interesting whether you are considering left side or right side. Whether you are considering left side or right side for this particular problem, its reaction force becomes important. Reaction force becomes important. It will come. So to draw the free body diagram, entire truss, I am not drawing here. This is roller. Remove this and show this. This is hinge. So show this. This take moment with respect to A. Entire truss equal to 0. Get this say NB Y. This is X. This is Y. Summation X. Summation Fy. This is NAX. NAY. Those unknown can be calculated first. Reaction support, you calculate the reaction forces due to the free body diagram of the entire truss. Then, as I told, as per the assumptions, I am not drawing entire things. So maybe there are two sections I can consider. Section 1, this is section 2. If you consider section 1, and this is the first assumption, Fn and Gm are tensile. If you consider section 1 and take section 1, take right side. Let me draw once. Let me draw this. Okay, dimensions you will get as it is 45-degree right triangle 1. So we have considered this right side one. This is NV Y X Y. Now already I told this D is 0. That is the inspections you can get. So we are here. So we'll show here. This is M. No. Which cross sections I have shown? I have shown this along with this, along with this. So this is N, and this is M, and this is F, and this is E. Okay. And our assumption was Fn is in tensile. So Fn is in tensile means this is tensile. Fn is tensile. Then there will be another force Ef, and this is our sections. So another force will be Mn, one force, and this is Fn. It is towards this F, and it is towards M. So summation Mf equal to 0. If you equate from this, you will get Mn value. If you take moment respect to F, you will get Mn value. Then summation Fx equal to 0, summation Fy equal to 0. That will give Fn value, Mn value, let me write this. Mn value, how much you will get? Mn value you will get 20 kilonewton tensile. Fn you will get 84.5 kilonewton tensile. Okay. Then second one, instead of this section 1, you take section 2. Similar approach you can do, taking them from the right side. So what we will do, second one, if I change this color for second case, second case, it will be continuous here. So second case, section is here. So draw this, and this is the, consider this is the sections, maybe different color, use this. For this is 1, this is, so this, in that case nothing will be there, correct? And this, similar way, this point will be in that case G. So take moment with respect to G, you will get Lm value. This will be Lm. Then summation Fx, summation Fy, 0, you equate. It will be Gm, and this force will be Gf. Then you can calculate the value of Gm, and you can see the Gm value is positive. So that means you are correct. As problem told, Fn and Gm you have considered, that is correct. Those forces are positive, tensile. So no need to reconsider. If it was wrong, any one of this, then you have to redo from the beginning. Any doubt for this problem? Do you have? Yes or no? Any doubt do you have? No response. That means no problem. Okay. So for these problems, for entire truss, you have to draw the free body diagram for the entire truss and get reaction force Ny, then Ay, Ax. Ax will be 0. Ay will be from that free body diagram. You can calculate Ay value also. So let me check. So you can calculate. I don't have solution now. Okay, you can calculate the value. Now next is we have to, it is told that angles are either 30, 60, 90, 120 degree. You can see which one is what. Now we have to calculate unknown force JQ. What is JQ? J JQ. This one. This unknown force you have to calculate. This unknown force you have to calculate. Now, say maybe what we will do, we will consider only right side one, right portions. So we will take sections. I'll tell you. I'll take these sections. So this is the sections. Now you have to tell me, if I take sections, how many forces will be exposed there? Students, you have to tell me how many forces will be exposed. If I take four, yes, but we know that maximum unknown we can calculate. One is moment balance and two say force balance. So maximum unknown can be 3. So it is some issues. So to solve that, what you have to do, initially we will take these sections. Now how many unknowns? Section 1.
3.
Yes. And we will consider right side only. We will consider right side, these portions. So now we have 3. So we can calculate GH, QG and WX. These 3 we can calculate, correct? Now you consider out of these 3, I want to utilize WX. Only calculate WX from section 1. Then use section 2. In section 2, this is known. WX is known. Now this unknown can be calculated.
Yes, sir.
Okay, that approach you have to consider. First take section 1 to get the unknown WX. Once that is been calculated, then move to section 2. Then force will be exposed as W or XW, Q, XW, XQ, JQ, JH. Out of this, you already know the value of WX. So 3 unknowns. So 3 unknowns can be calculated accordingly. Okay. So best idea to calculate that one, you can this one, you can take also M, J, G and equal to 0. This one, like this. Why I am doing this? Because the force here, XQ will pass through the imaginary line G. So imaginary point here, this point G. If XQ you extend, it will pass through point G, and JH force will also pass through G. Okay. So two forces we can have that way, that WX multiplied by this distance, maybe distance is L, this to this, and this is taking moment. So this is anticlockwise, minus JQ multiplied by this perpendicular distance. Maybe that is L, maybe that is L prime, that equal to 0. So JQ equal to WX multiplied by L divided by L prime. Now from the geometry you have to calculate what is L prime, what is this distance L. There will be some relationship, as all angles are 30 degree or 60 degree or 90 degree or 120 degree. That's all. Okay. Any doubt up to this? Okay. Then somebody asked questions regarding the frictions. Okay.
No, sir.
Done. Friction problem solved.
No, sir. I said no doubt about
Okay. No, for friction, somebody is having some doubt. Somebody
Yes,
is
sir.
asking.
I had a doubt, and sir, it's not particularly about friction. It's a general mechanical.
Yeah, tell me. Yeah, sure.
Sir, if we have a rod and it's pressing against the surface at an angle, will the normal reaction force be along the direction of the rod or perpendicular to the surface?
Perpendicular to the surface.
Okay. No matter which angle the rod is in.
No. It is not. What will happen? I'll tell you. Actually, that surface, if we consider this point load, so surface is point load, 2D case, correct? It is point load. So, which problem you are talking? Let me check. because okay, just a minute, because I may give some wrong answer also. Let me understand your problems. Then this is, let me check. You tell me which problems here. Any problem you tell me.
The second problem, sir. The second problem, the rod AB. While looking at that, I got this question.
This one. Okay. It is okay. You see, if you exaggerate this is like something like this, correct?
Yes, sir.
So if this is the surface, if this is the bottom, then reactions is this. Yeah. This will be the reactions perpendicular to the surface, normal to the surface.
Okay, sir.
Say here also the normal to the surface. One is normal to the surface. If there is some frictions, accordingly to get the equilibrium, you can get the, or due to the application of the force, you can get the tendency of the movement, whether it is static, if it is in equilibrium, static equilibrium, but there will be some tendency to give the to have some rotational or translational movement tendency, and friction will opposing that one case. Other case, sometimes what is happening, friction is helping to have some motions in some directions. So equilibrium condition will give you the idea. Okay.
Yes, sir. So according to what I understood, at point A, the normal reaction will be perpendicular to the surface.
Yes.
And the reaction force is equal to the sum of the normal force and friction force?
Resultant. Resultant of that.
Exactly.
Yeah. Yes.
Yes, sir. And I think the next question, sir, in the eighth problem, same assignment.
Yes. Yeah.
Yes, sir. In this one, we are supposed to find the tractive force from the tires on the horizontal surface.
Correct.
So could you please explain what that exactly means?
Actually, see, target is we have to lift this block. Okay. So to do this is one reaction, other is this reactions here, correct? Now,
Yes.
if I draw the free body diagram of this structure, this one. So basically, if this is giving the force here, there will be some reactions for this structure. Okay.
Yes, sir.
Truck. So if this is the reaction force like this, so there will be some self weight. So there it will be balanced like this. Okay. It will be balanced like normal force. So
Yes,
there
sir.
will be some frictions like this. This friction F1 and F2, and if this is say N, so it is F1 plus F2 minus N will be 0, xy, correct? Summation Fx 0.
Yes, sir.
That indicates this F1 plus F2 equal to N. Is not it?
Yes, sir.
Actually, this is N, and this is N, this is also N. Whatever the force that industrial truck will impose in horizontal direction on the paper, this is 30-degree inclined. Okay. This is roll. This moves solid roll of paper. Whatever the force will be imposed by this truck will give the reactions same amount, that will be adjusted with this frictional force. And this is P. Sorry, this is P. Okay, this is P. It is told that compute the required tractive force between the tire and the track and the horizontal surface. Tires of the truck and the horizontal surface. That is F1 and F2, isn't it?
Yes, sir. I understand.
That is P. Yes. That's why this type of movement, when you want to impose, their friction is our potential. We want to apply the potential application of the frictions. Yes.
Okay, sir. So the force that the truck can apply is limited by the friction between the tires.
Yes.
Tires on the ground.
And due to the equilibrium, it says that F1 plus F2, maybe it is dynamic equilibrium, maybe it may not be static conditions. Okay.
Okay, sir.
This F1 and F2 must be same as P.
Okay, sir. Thank you, sir. My doubts
Yes,
are
yes. Okay, welcome. No doubt, correct? Any other questions? No. Okay, fine. So, guys, almost I think we're 10 minutes, 20, 15 minutes ahead of the time. Very good. I have finished that syllabus. Now, if you have any doubt, we can discuss now regarding the
I have
exam.
a general question, sir, regarding
Yes.
the exams and the preparation. Sir, during your classes, I would like to make some notes and all that. So could
Yeah.
you suggest what exactly should we make notes of? What points should we note down?
Okay. Actually, whenever I am discussing any of the problems, so I believe you must have pen and papers. Okay. So whenever I am explaining some of the new topics, okay. First of all, you write that topic name, then some expression I am writing, correct? Quickly, you can draw those type of free body diagram because those are very important. Okay, and if I'm explaining something, if you can quickly note down the meaning of this gist of the explanations, or else second option is that after the class, very carefully, okay, with your headphone, you listen to the lectures, you stop if you are not able to understand, go back once again, listen to that, take your book, textbook, the Merriam and Craig. From there, mainly this assignment has been, this study material has been created. You will get relevant explanation in the books also. Sometimes what happen, actually, although I used to tell that this is the only one book you should read, you should read. But what happened during the explanation, maybe that explanation is the outcome of my last 20 years of experience in working in the aerospace field or engineering field. Okay, that may not match exactly with the book, but of course, along with this class note, lectures, video lectures, okay, along with the books, hopefully you are supposed to have sound background of the engineering mechanics, and that's supposed to be your backbone in your engineering, especially for mechanical, aerospace, mining, civil, metallurgy. Okay.
Sir,
Yeah.
friction, can you please show number 12?
Yes.
Thank you, sir.
Yeah. 12. This one. Okay. I have not explained this before. Okay. No problem. So what is happening? You try to understand that only the couple has been applied at the lower uh, cylinder. Both are 20 kg cylinder, and which will allow them to roll slowly down. It is not moving up, although some force has some couple has been applied. It is moving down, slowly moving down the incline. The coefficient of static and kinetic frictions for all contact surfaces are given. Okay, point 0.6 and 0.5, mu s 0.6, mu k. You have to calculate. You have to calculate the couple M that is applied to the lower cylinder. Now you can consider that this type of problems, which location slipping will start, A, B, or C. There are two places that are contacts, correct, as a whole. So you have to consider which place that slip will start. Let me draw the free body diagram one by one. So this is one, this is two. Okay, this is basically A, and this is a B. So, as per the problem given, we can expect some reaction force for this. Now, this is the contact here. This is A, B, and this is C, correct? This is C. So, we are expecting this is the normal forces. This is the normal forces. And both are 20 kg, correct? So, here 20 G, 20g, this is the self weight. So we can have idea that angle is 15 degree. Now this couple has been applied here, couple M, and it is moving slowly down. If it is moving slowly down, then friction force should act in which directions?
Upward directions.
Upward directions. So we are expecting that friction force is acting into the upward directions. So friction is, this is the F1. Okay, this is the F1. Now, and this is say F3 frictions. Okay. Now, if it is moving down, then which direction friction is supposed to act here? See, maybe here. Which direction, upward or downward?
Sir, on the wheel B, the friction should be upward, and on wheel A, friction should be downward.
Okay. Because you want to take moment balance here, correct?
Okay, for moment balance.
That is also true. You are right. If you take moment balance, it is confirmed. This is anti-clockwise, this is clockwise. You are true. Whatever you are thinking, that is also true. So this is F2. Okay, this is F2. So this is, or I write here the F2, not here, this F2. Now question is, free body diagram we have drawn correctly. FBD of lower cylinder, FBD of upper cylinder. Now question is, out of these three frictions, F1, F2, F3, my question was that which location slipping will start first? Slipping will start at A, at B or C. If we understand that point, very simple way we can solve the problems. Which locations?
So I think it's going to start at C.
Yes, because that reaction will be the lowest one. Okay, if I write this is Na, Nb, say Nc, this is Nc. Nc is lower than Na and Nb. Okay, so slippage or slipping occurs between two cylinders. If it is so, then this F2 equal to actually mu Nc. That limiting case we can apply. Only for F2 we can apply. F2 equal to mu Nc. F3 equal to mu Nb, not, it is wrong. Okay, F1 equal to mu Na, that is wrong, because slippage has already started at between two cylinders. So you use this expression, limiting case, and take, say here, moment with respect to B equal to 0, then you will get, see, F2 equal to F3 equal to mu Nc. Is not it? So from that, here this F2, this expression you can get F2 equal to F3 equal to this expressions. So what you have to do, whatever the free body diagram you are getting, from this one, you have to equate everything. Finally, you will get all the unknowns, and this torque will be F1 minus F2. F1, F2, there will be some difference multiplied by R, because when you are talking moment with respect to this point, you can see N2 is passing through that, N1, NA, NC is passing through this point, NA is passing through that one, weight is passing through that one. So F1 minus F2 multiplied by R. R is the radius. Okay, 300 by 2 of the
Sir,
cylinder.
we are taking the torque about the center of mass, right?
Yes, CG. Yes, yes. Center of mass. That's why that moment, whatever couple you have applied, that is basically this.
Yes,
Whatever
sir.
couple you applied, that is basically F1 minus F2 multiplied by R. So if you can calculate all the unknowns from these assumptions only, what correct free body diagram you have to draw as I have shown, then you have to consider only one case, that is limiting case, F2 equal to that is slippage will start between two cylinders. Then you can use F2 equal to mu NC. This limiting F equal to mu N, that expression you can use only for point C. Then take moment balance, moment equilibrium for upper cylinder to get these expressions, and other expression you will get. Finally, all unknowns will you can calculate, and you can have this couple value. If I go for the values, let me tell you, F1 is, let me check it, F1 is around 206 Newton. Then sorry, not F1. It is NA. Then NC is 33 Newton. Then NB is 1726 Newton. Okay. NA, NC, NB. And if you use this one, if you do this one to get the limited case, say F1 N1, F1 by N1 you will get 0.41, not F1. Let me check which one is 1. Yes, F1 N1, yeah. And F3, this is not N1, it is NA. F3 NB equal to, you will get 0.05. So all are less than static frictions. Okay, that will ensure that slippage will not start here and here. One thing I should tell that when you will use these expressions, the mu value basically, initially mu value you have to use mu k. Yes, any questions? Tell me. To calculate F1, F2, F3. Yeah. Any question?
Thank you, sir.
Yeah. You do this, definitely you will get this answer. I will tell you once again, the slippage will start between two cylinders. So at the NC, the friction is the limiting case, that is basically here F2 equal to mu NC. We can apply this limiting case only once. Then if you take free body diagram for the upper cylinder, then F2 equal to F3 equal to mu NC, that expression we can get. Remaining thing is to do the calculations. Finally, you will get the unknowns F1, F2, F3, NA, NB, and whenever you will get the expressions, at it is told that it is moving slowly down the incline, you can use mu k in that expressions. Mu equal to mu k, for that expression you will get, or maybe I'll tell you here itself. This is right. This mu equal to mu k. Okay. That way you can utilize. And finally,
so
you can
slippage will be there only at C, right?
Yes. Why it is C? Why it is C? Because this, you see, this is N1 is around 200. At C it is 33 Newton, and at B it is around 1726 Newton. Of course, it is very less reaction force, and coefficient of frictions for static, everything is 0.6, for dynamics 0.5. So mu limiting case for A, B and C, if you consider limiting case for A, B and C, rather reverse we can try. F A limit, F B limit, F C limit. Okay. If you use this 0.6 multiplied by the value, 0.6 multiplied by value, you can see that limiting case for A is much higher than the FA. Mu B limit is much higher than the FB. That will ensure same thing. I have shown here using this expression N1 by F1 by N1. Instead of that, it may be convenient for you that you use FA limiting value this, FB limiting value, FC limiting value. FC limiting value already you have considered. And if you see, FA limit is much higher than the FA, FB limit is much higher than the FB. FA equal to basically FA equal to F1, FC equal to F2, and this is FB limit is F3. That way also you can show you that only slipping will start at point C. That was our initial assumptions. That is correct. If you are wrong, you have to redo this. Okay, any doubt?
No, sir.
Okay, fine. Then I can stop presenting. Okay. So,
Sir,
yeah.
sir, I have a doubt, sir. Sir, in Truss problems, so should we write the expression in all problems at first that m plus 2j equals to 3, so the equation satisfies that the body is internally rigid?
Okay.
So should we write?
Yes. Question
Rahul,
is,
your mic is on. Could you please switch off your mic?
yeah. Somebody, yes. Everybody should mute yourself. Yes. Rahul, you can mute yourself. Yeah. So question is like m that should check whether the structure is stable or not, internally stable or maybe externally stable. We are using to check the condition for stability rigid structures. Rigid means internally rigid when load has been not applied by checking that m plus 3 equal to 2j or m dot equal to 2j dot prime basically. Those checking is required to check that structure is stable or not. Now question is whether in your answer you have to give that one or not. May not required if I am not asking you. If I ask it in the question, then only you can provide. But that will give, why I told that one to check at your own, that will give you the confidence that if it is like with some deficient structures, you cannot take the moment. That idea will be revealed from that expression. But in questions, it is not mandatory. But if you are very confident, in a short time you can give, it will be added advantage.
Okay,
Rahul,
sir.
understood? If you give that one, it will be added advantage for you. Okay. Any other questions?
Sir, can you confirm the attendance once? I think I missed it due to
Yeah,
network
just a
issues.
minute. Okay, just a minute. Okay, I have stopped the recording. Rahul, take carefully, offline, I am telling. Say for example, you got in exam, hello, Rahul, you got in your exam, final exam 89. Then I have in a serious positions that whether I will give you 90 or 88. Then what I will do? I will go back to your attendance, your assignment, whatever the basic things, understanding you have expressed in your answer script. If I am happy, I will give you 1 or 2 grace marks. I can give you. But are you deserving 90 from IIST Shivpur mechanics subject? Yes or no? That answer lies in minute details of your answer script. I think you are intelligent enough. All students got my point, correct? Sequence, try to understand. First, I will go for the attendance, whether my students is attending my class or not. Okay, because that is very special case to give you some grace marks. Then those case, this will be very much important. Your seriousness in the assignment, okay, the way you have written the assignment, everything will be re-evaluated. Or else I'll put 89, leave it, let it be. Understood? But many times I do prefer instead of giving 89 or 88, that is true for 48 also, 38 also. Okay. Okay, 38, 39. Okay, maybe 78, 79. Sometimes I used to go back to the assignments to check whether I can give you some grace mark or not, if possible. That depends
Okay, sir.
upon many of your. You understood my point, no?
Yes, sir. So means you are telling that after the main exams you give a little bit grace marks based on the assignments, right?
No. First of all, it will be whatever you have whatever the things you have done, I will check accordingly, and I will give the final marks. Sometimes what happen, I am getting some students are getting say 88. Okay, then I will try
Okay,
whether
sir.
I can give you 90 or not. On basis of what I can do, additional what informations I need, minute details of your answers. Understood? So first thing I will check the
Okay,
attendance.
sir.
See, grace mark is up to me, correct? Not always it is true. You are getting, say for example, you are getting 83. Should any grace mark will help you? Do you think? No, correct?
No, sir. Yes, sir.
Yes, sir.
Yeah. So only special case when it is. So first of all, I will go for attendance. That is the first thing I should do, correct? Then I'll one by one I'll go. That's why always it is a good habit to give one minute details of that answer, provided time permits. Say in midterm, I will tell you answer these three problems, and time is given only 45 minutes. Okay, so you are not getting time that much. So in that case, you can skip it, is not it? But in your assignment, you have the provisions to show you your seriousness and your major understanding of the subject. Okay. Okay. Any question?
Sir, actually, I missed today's attendance, I
Yes.
think,
Sure.
because of my
Sure.
busy
Sure.
schedule.
Just a minute. Your name?
Shreyas Kumar,
No. Enrollment number.
052, mechanical 052.
Just a minute. Mechanical 052. Yes, given all. Just a minute. Once again. Hopefully, you are the class representative, I guess. Correct?
Yes, sir. Yes, sir.
52. Okay. Not given. Yes. Now it is given. Okay. Yeah.
Okay, thank you, sir.
Okay. Welcome. Okay. Is it okay, everybody? So I have 2 minutes.
Hello.
Yes.
Yes, sir. Attendance, sir. IT 56.
IT.
As a judge.
Yes. Your name?
Rahul Kumar.
Sir,
Just a minute. That's
electrical 56.
Rahul given. Electrical 56.
Mining 27.
Okay, just a minute. Electrical. Your name? Electrical 56.
Suman Muntri.
Shuman. Yes. Given. Next.
Sir, mining 27.
Mining 27. Your name?
Swaraj Paul.
Yes. Given. Done. Now. Okay.
Thank you.
Okay, all the best. So be in time. So once what we'll do next day 3:30 for class test. Some sort of camera checking you can do with me. Okay, then we'll fix some time. I will post that assignment, and after 45 minutes, I will take 10 minutes to upload that one. Okay, and if something happens, need some extra time, maximum 1 hour can be allowed total. Okay. Okay, guys. All the best.
Thank you.
All the
Thank you,
best for
sir.
the next day.
Thank
Bye.
you, sir.
Okay. Bye.
Thank you, sir.
Bye. Bye. Bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Bye. Bye. Bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.